Back again, gentlemen. Before this is over with, this is probably going to be a 3 DVD series, probably with about 6 or 7 hours of video. But while we're waiting on our silver to finish up over there in the Buckner funnel, I wanted to show you what we was going to dry it in and give you a little bit of background as to what this stuff is right here. Now, this is called pyroceram. And this stuff was initially developed for military applications. This is a good example of something that was developed for a military application being introduced into the consumer market. And what they used this stuff for was the tips of the cones on missiles, the radar dome that went on ICBM missiles. Because as you know, when something goes up and re-enters the Earth's atmosphere, it becomes very, very hot. And you'll hear people talk about pyrex and how it could take heat. And nowadays, everything is not made equal. Most of these pyrexes that you buy will break. This stuff was originally developed in the 1950s and released as a cookware after its military application by Corningware. And this stuff right here will take some heat. Now, the one I have on the right here, I have actually taken a blowtorch and heated this stuff until it was red hot, and you can drop that into a thing of water and it'll come out just exactly the way that it went into it. Now, you'll need this for drying your silver, and you could pick this up on eBay very easily. Most of mine I find at trade days, swap shops, yard sales. I think I give $5 for this one right here is what I give for it. But there are some imitations out there, unless it actually says on the top of it Corningware, and you'll notice that it says P-2.5B made in the USA. The P designates that this is pyroceram. I call it pyro cream sometimes. Pyroceram is the actual name of this stuff. I give it my own nickname. But once your silver gets through getting cleaned in the Buckner funnel, you're going to set this on a hot plate and you're going to dump your silver crystals in here, and you're going to turn it on so you can dry your silver in preparation for getting ready to melt it into shot so that we can use it in our silver cell. But this stuff, if you'll look, the blue cauliflower on it, the design, notice the same here. Now, sometimes it'll have orange pumpkins on it. It'll look like a, what do they call that from Thanksgiving? A cornucopia, I believe is what it is. It looks like a horn, but it will always be marked on the very bottom. It will always be marked Corningware and designated with a P sign on it. So, anytime that you see that, you know that you have actually pyroceram. So I think I give $5 for that at trade day, and I might have give $3 for that. But this is one of the best pieces of labware that you will ever find as far as taking heat and thermal expansion. Okay, now let's get back over to our Buckner funnel and see how we're doing there. Okay, our solution's starting to drip pretty clear. So this is probably this is the 4th rinse, maybe the 5th I've done. I kind of lost track a second ago while I was trying to do all these other things. But if you look down here at the bottom, notice the drips. They're clear, and that's what you're looking for. As long as you've got clear drips, you've pretty much got as much of the nitrate solution out of there as possible. And what you want to do at this point is you want to allow the Buckner funnel to suck as much water out of this as you can until there are probably just a drip every 10 to 15 seconds. You want to make sure that it's good and dry. It don't have to be perfectly dry. And what we're going to do is we're going to dump this in our pyroceram, put it on heat, stir it around with a stainless spoon until it's dried, and then we're going to melt it into shot so we can use it in our silver cell. Alright gentlemen, it's took about 5 minutes, but if you'll notice now, the drips have slowed down to nearly nothing. So what we're going to do at this point is we're going to remove the top of our Buckner funnel, and we're going to take this over and we're going to pour this in some pyro cream, and we're going to start to dry this out. Alright, here we are with our hot plate set up, and I'm warming my pyroceram up, and I've got another piece right here. Now they make this stuff in just about every known shape and size that you could want. And earlier you heard me talking about that wasn't the only type of insignia that they have on it. Well, here's one that has that type of insignia on it. And as you can see from the bottom, it is pyroceram. And inside of this, I've got some silver shot that I've already poured just to kind of give you an idea of what your cemented silver will look like whenever we're finished pouring it into shot. I'm trying to get a better zoom in there, but it don't seem to be wanting to cooperate. But that's what your shot will look like. So now what we're going to do is we're going to take our Buckner funnel with our cemented silver in it, and we're just going to flip it upside down and shake it one good time. And see, all of that nearly came out of there. And that's basically it. It's almost clean now. I'll take something and I'll knock that last little piece off in there. And your filter papers usually just come right out. And there may be a little residual left on your filter papers, but it's usually so dry at this point that it'll pretty much come off of there. And you want to save these filter papers, and you want to put them with your other filters inside of your plastic bucket to save for processing later. And now I'm just going to take a glass stir rod and kind of break this up a little bit. Move it around in the bottom of the pan. Oh wow, look at there. Well, this is a prime example. Right here is a piece of copper. Now, whenever you do your precipitation, it's best to do it with a piece of copper plate. Now, this was left over from my plate. Now, you could either use a piece of copper plate, like this right here. This was part of a copper bus bar is what this was that I got from the local scrapyard. Or your second choice can be copper pipe. And your third choice would be copper wire. But the thing I don't like about copper wire is that the silver precipitates from the solution so fast that it tends to encapsulate the wire. So you wind up with a lot more copper in your cemented silver than you really want. But if you find any little pieces of copper in there, just reach down in there and get them out with your hand, or use a spoon or a fork or something other to remove them with. Now, the silver cell is tolerable of a little bit of copper, and the way I've set up the solutions and the concentrations that I'm going to give you for making your solutions, you'll be able to tolerate about 98% silver in the cell, with the other 2% being copper. So if there's a little bit of residual copper in there, it's alright. But if you find any bigger pieces of copper, you really want to remove them. Now, I'm going to let this dry for about 15 or 20 minutes and cut away, and then I'm going to come back and show you what this looks like dried before we take it outside and we melt it into silver shot like this for the silver cell. And I'll see you gentlemen in just a few minutes. Once you've cleaned all of your cemented silver, you want to take the wash water that's left over, like this right here, and you want to pour it into a 5-gallon bucket. You need a separate 5-gallon bucket with a lid. All of your spent solution, like the copper nitrate and the silver, well, it should be all copper nitrate now, but there may be some residual silver in that nitrate solution that didn't precipitate, so you don't want to lose that. So you want to take that as well as this, and you want to place it into a 5-gallon bucket, and in that 5-gallon bucket you want to add a piece of copper, because if there's any residual silver left in the solution, it will work to drop it out. That way you don't lose any of your silver. Good afternoon, gentlemen. I'm getting ready to get this silver ready to melt into some shot, but I just wanted to show you an example real quick of something other. What you're looking at right here, that's the real white looking silver, that is a good clean silver product, and that's what you're looking for. Now, over here on the right, you'll see this darker material. This was the very last of the material that I dropped with copper, and it has a lot of copper in the mix. That's why it's dirty. That's why it looks the way it does. Now, you could still put this in the silver cell, but you will only be able to run about half as much of this type of material before your electrolyte is spent as you will this type of material. Notice the difference. We put them side by side. Well, I can't really get them side by side here, but you can get an idea right there. One is real white and one is real dark. This is clean and this is full of copper. Good afternoon, gentlemen. Now that we've dried our silver, our cemented silver, what we're preparing to do now is to melt it and pour it into shot so it can be introduced into our silver cell. And if you'll notice in front of me, I have my cemented silver, I have a melting dish, I have a set of tongs to hold the melting dish, and I have a piece of pyroceram, and I have a 5-gallon bucket filled full of water. Now, a point that I want to make is if you don't have a set already, get a set of these tongs for holding your dish. They're great. You can get them for like 15 bucks off of eBay. You can get these dishes off of eBay. And this one here is a dirty dish. And the reason that we're using that is because our cemented silver is still dirty. It still has about 1 to 1.5% copper in the cemented silver. So what we're going to do is we're going to use a dirty dish first to melt this in the shot. You will need 2 of these dishes, and I will explain to you later what type of dish this is. And if you'll notice, this dish has a glaze on it. You can't just use these dishes. When you first get them, they're going to look like this plaster. They're going to be dull. And you're going to have to glaze this dish. Now, once we pour our shot and we run it through the silver cell and we have pure crystals, I'll come back and I'll show you how to glaze one of these dishes and get it ready. But since I've already glazed this dish and I've already used it, we're going to go ahead and use this for the presentations, what we're going to do. And what we're going to use for melting our silver is a propane oxygen torch with a rosebud tip on it. And if you don't know what a rosebud tip is, Google it. And this one I've used quite a bit, and it's kind of corroded on the end, but it still serves its useful purpose. I've made a lot of money with this torch right here. But this is just a propane and an oxygen torch, and I'll show you my tanks outside in just a second so you can get an idea. I ordered this torch with the hoses off of eBay for $100 bill, included shipping. The only other thing you need besides that is an oxygen tank, which can be picked up at any welding supply store and cost about $20 to get refilled. The other thing you will need is a propane tank, and the type of tank that I use is just a tank off of a barbecue grill. It's just a regular barbecue grill propane tank that you can get refilled. You can pick them up at Walmart, Lowe's, anywhere like that for about 20 bucks. Now let me go outside and I'll show you what my tanks look like. Okay, here we are outside, and basically all this is just an oxygen tank with a set of regulators, and we have a propane tank just like the kind that you would find on a barbecue gas grill. Now inside, when I'm working in my laboratory, I have an oxygen hydrogen torch that I use for melting my other metals with. This tank and setup here is just one that I used to use, that I just use around the farm now, but I just wanted to give you a general idea. The oxygen tank cost me about $20 to refill. The propane tank, about $20 to exchange at Walmart, Lowe's, like I said, any place like that. So altogether, I have $100 in my torch and about $40 or $50 in my gases right here. And this will last for quite a while. You can melt literally several thousand ounces of silver or gold with this type of propane tank setup here. Okay, gentlemen, I want to take just a second to explain to you a little bit about my torch setup here. I've got two different type torches. I've got my oxygen propane torch, which is a map torch, which is supplied from my tanks outside, which you just saw. And then we have a small torch here that came from Lowe's. And for melting maybe an ounce of silver, that little torch right there would probably work. But if you want to melt larger quantities of silver, you're going to need a torch with enough output. And it's not that both of these torches don't get same temperature, because they're both burning the same gases in the same ratios, so they achieve the same temperature. The difference between these two torches is the BTU output. This torch here can only supply a certain amount of BTUs to melt a certain mass of material. You can only output so many BTUs from this little bottle right here. But our other torch that is supplied by our gas bottles outside, you're able to adjust the amount of oxygen and gas that goes through the torch, so you're able to supply more BTUs. And that is what's going to keep your silver molten, and that's what's going to determine how quick that your silver melts. So again, the smaller bottle is great. I have used them for like an ounce or so. It takes longer because it doesn't put out as much thermal energy compared to our larger torch here. So what I'm fixing to do is I'm fixing to get this set up here, and we're going to go ahead and melt our silver powder into silver shot to get ready to introduce into our silver cell. And what we're going to do, since I have my pyroceram here, I'm going to go ahead and show you. I have a 5-gallon bucket, just a regular 5-gallon bucket full of water here. And we're going to take our pyrocreme and we're going to submerge that right in the bottom and just let it fall down there. Because when we pour our shot into this water, it's still going to be hot. As it travels through the water, it will start to cool and solidify. it will hit the bottom of the pyrocreme and finish cooling off in this cool water. Now, if you didn't have this pyrocreme in here, what would happen is that silver would still be warm enough that when it hits the bottom of this bucket, it would literally melt right into the bucket. So as we heat our silver and we stand over this bucket of water, we're going to pour it in and kind of try to make sure that we hit the dish. Now, one or two little pieces may travel outside of the dish there, but that's all right. There again, we just want to make sure that we get the majority of the silver right in the middle of the bucket so it collects in our pyrocreme dish in the very bottom. So let's go ahead. I'm going to cut away for just a moment, and I'm going to go ahead and get this set up, and we're going to start melting our cemented silver in the silver shot for introduction into our silver cell. Alright, gentlemen, now what we're going to do here is we're going to take our tongs. Again, you can get these off of eBay or off the internet for about $15, and these are handy. You don't want to be trying to handle this dish. It's going to be hot, so you don't want to be trying to handle this with any type of pliers. I've seen people use pliers. Not saying that that's the wrong thing, but the safest and most productive way for me is to just use the tongs, and you just want to take the dish and they just sit in there by spring action, and this holds your dish. Now, what you don't want to do is just take your torch and go to heating this full blast, because as this dish expands, it has moisture trapped in it. And again, we're in Alabama. It's very humid here, and this dish retains moisture. And what happens is if I heat this dish too quick, this will expand and the dish will actually crack. And back when I first started learning how to do this, I cracked several dishes, and even though now that I know how to do it, I don't do it nowhere near as often, but I still make mistakes. Nobody's perfect. So the first thing we're going to want to do is we're going to want to take our torch, turn it on, get a little propane going, and then we're just going to add a little oxygen to it, like that right there. And then we're just going to take the torch and lightly play it across the dish, heating it up a little at a time. Again, we just don't want to go to blasting heat in this dish. You want to move it around, kind of make sure that you get all the moisture out of the dish before you go to heating it. And here in a few minutes, when we really get this dish hot and start melting silver, this dish will be going red hot. And I recommend that you get you a piece of steel or something to set this on. This is a wooden table right here, and as you can see, I've got burn marks all across this table right here. So just play it around and start to heat it up. Now what happens is if you put your cemented silver in this dish and then go to heating it, you're going to have a cold dish, and it's going to take a whole lot longer to get that silver up to melting temperature. So let me set this down for a second. I have a metal tray. I'm just going to set this on there. And we're going to just heat the dish. And we're going to turn our oxygen and our propane up just a tad. And as you can see, the bottom of that dish is starting to glow red hot. That's what we want to see. And we're just going to increase the BTU output a little bit. And here's where this torch excels over the torch that I showed you earlier with the smaller canister. You can produce more heat in less volume with this torch than you can with the other one. And for melting nearly this 100 ounces that I have over here, you want to use a bigger torch. It really makes life simpler and cuts your processing time down dramatically. And you can see our dish starting to heat up there. So what we want to do at this point is we want to go ahead and get some of our silver up here. And then we're just going to get us a spoonful and we're going to transfer it over here in our dish. And I recommend, if you're starting out new at this, just do small portions. It's a lot easier to melt small portions than it is to melt a very large portion. And if you'll notice, our silver starts to bead up and starts to melt immediately. And we're going to increase our heat. And watch our silver start to melt. Now, silver is a heavy element, so you don't really have to worry about blowing this stuff out the dish. I mean, you have to get really, really crazy with it in order to blow it out the dish. And as you can see, our silver starts to puddle and it starts to melt. And I'll pull this torch away in a minute and I'll let you get a good look at that. And again, I've done this so long that I don't wear any type of gloves or anything. But if you want to get you some leather welding gloves or something other, because, you know, you don't really like the heat that's produced from this, then I would recommend that that's what you do. And notice, for that large volume of powder that we put in there, how much that it's reduced to. And we can start to see our silver roll around there. And I'm just going to go ahead and add a little more in here. Now you want to make sure that your silver powder is good and dry, because by adding that powder to that hot molten silver like that, you can have a steam explosion. And I would recommend that you wear gloves and that you wear the proper safety and eye protection, just to make sure that if you do have any accidents, that you're protected. And again, we can start to see our silver metal roll around there. And I'm going to add just a little more, again, being very careful to make sure that you don't have a steam explosion or that it pops out on you. Now the further we get into this process, the quicker this silver will start to melt, as our dish has already reached the optimum temperature for melting. And of course, the more silver we introduce into our dish, the higher the temperature we're going to, well, not the higher the temperature, but the more BTUs we're going to have to maintain to keep that silver in a molten state. And what you're observing on top of that silver is other oxidized metals. Remember, we have copper in here. So you're going to have some copper oxide that forms in the fluxes that are on top of these metals. And you don't have to add any type of flux to this, none whatsoever. The dish is fluxed, that's all the flux that you'll need. And our silver is getting good and molten now. Now what you want to do before you pour this out of this dish is, if you tip it up right now, the top of this dish is cold. This metal will freeze as it pours over the top of the dish. So you kind of want to heat the lip of the dish while you're bouncing the flame off of your silver metal. That way you're melting the tip of the dish as well as keeping enough heat on the silver to keep it in a liquid state. And once we get it to a good warm temperature, we're going to move it over here, over our pyroceram, holding it above the dish, and we're just going to pour. Notice that all the trash that was on top of it is trapped on the side now. And that's why I've used a dirty dish. I don't want to mess up a clean dish for melting a dirty material when I don't have to. And then after we poured our shot, we just want to heat our dish a little bit more. And most of those oxidized metals are either burn up or they absorb into the borax glazing that's on the dish. And we're going to add some more silver. And we're going to start our flame at the top and lightly make our way down with it. And as you can see, our silver starts to melt again. The hotter you get this dish and the more times that you use it, the easier the silver will start to melt because the dish and the material is already preheated. And as you can see, the silver is starting to get to a molten liquid state. So we're going to add a couple of more spoonfuls. Again, being careful to make sure that you don't have any type of a steam explosion. If this material is moist when you introduce it to a hot metal, you will have a steam explosion and this stuff will pop all over the place. Now what I'm melting here is what I showed you earlier inside, the difference between the clean silver and the contaminated silver. Now I've already melted the clean silver and I'll show you here in just a little bit the difference between clean silver shot and dirty silver shot. And like I said, if your silver has a little bit of excess in it, it's not going to hurt anything. About the only thing it's going to hurt is it's going to deplete your electrolyte solution quicker, so you're going to have to change your solution more often. And as you can see, our silver is getting molten again. And again, what you see on top that looks like a crust are the oxides that form from the melting procedure. I'm going to add another spoon or two full, and we're going to go ahead and pour this into our shot. And the reason that I wanted to demonstrate melting the dirty silver versus the clean silver is it'll take you a few times to get this process down pat. Even though I've made this video and I'm showing you how this done, there's really nothing like firsthand doing something other to get you an idea of what you should and shouldn't do. So even though I've made this video, it's still going to take you doing this several times before you get the hang of it, and the more times you do it, the better you're going to get at it. Repetition makes for good learning. Now, were this the clean silver that I had melted earlier, you wouldn't have all this oxide incrustation on the top of it. And once we get ready to melt our silver crystals from our silver cell, you will see the difference between the two. Our metal is actually molten under there, even though it doesn't look like it because you can't see it through the oxide layer. And again, we're going to kind of want to melt this lip right here so we don't have a cold pour. And we're going to move over here now. And again, we're just going to tip it up and we're going to pour that shot right in that dish. And we're going to heat it a little more. Our oxide layer is stopping our heat from penetrating to our silver underneath is what's occurring. It's actually acting as a refractory. So just tilt your dish to one side and heat it up, and your silver, it'll unsolidify. And if you'll notice, you're seeing green flames come off of there. And that green is the copper as it's evaporating from the heat coming off the dish. And again, just tilt your dish to the side and heat it, and all your silver will run down and collect in the bottom. And we'll heat the lip a little bit, and we'll pour this shot out. And again, we're going to heat the dish until we burn the oxides off here, and the rest of our silver gets freed up from the oxides. And I would suggest that you do this with a fan to your back or on a breezy day, because if you breathe the fumes that come off this, the oxides, the copper, and everything, you could actually get what they call metal fume fever. Go Google it. And what it is when you breathe these toxic heavy elements in like this, they collect in your body. You may have a headache tonight, you may have cold chills, and you may think you're getting sick or coming down with something or other, but the truth of the matter is it's from breathing the gases that are put off by this material as you're melting it. Now, if you have a furnace you can melt this in, then by all means do that. But if you don't, I enjoy doing things with a torch. For me, I have more control with the torch, and it's easier for me to handle my materials with a torch. And again, we're just going to heat this lip up here a little bit, making sure that it's hot. And we're going to pour some more shots. And I'm trying to burn some of those oxides away is what I'm trying to do. If you burn them away, it'll free your silver up. Your silver will run down to the bottom of the dish. And when you pour this shot, you don't want to pour it all in one stream. You want to kind of move your dish around a little bit, because what happens is it's still hot when it hits the bottom, and them pieces will actually mold themselves together. Now you can see some oxide residues that we have in the bottom right here. And I'm going to go ahead and cut away from the video now, and I'm going to go ahead and finish melting the rest of this, and I'll go inside and I'll show you gentlemen the difference between the dirty or the copper leaden shot that I poured and the clean silver shot that I poured. Okay gentlemen, we're back inside after having shotted all of our silver now. We have our silver over here in our pyro cream dish, and it's still damp. So what we're going to do is we're going to set it on a hot plate and dry it for about 15 minutes to make good and sure that all the materials are dry. Now over here I've set up an example, and I have 3 dishes across the top and a watch glass at the bottom. And in this I have 3 different types of silver that I've processed, and I want to explain a little bit about feedstock. Your solution in your cell, how quick your electrolyte is depleted, will depend on how trashy of a copper product that you introduce into the cell. Now remember, when we dissolved all of our sterling silver into a nitrate solution, we dropped it with copper. Well, our silver cell is basically the same. We will make up a pure nitrate solution of silver nitrate, and we'll start from there, and as more and more copper is dissolved out of the feedstock of the materials that we feed it, the more copper goes into solution, it starts to push the silver out of solution, just like it did whenever you use the copper to precipitate it from a nitrate solution. This way you're introducing it with your feedstock. Now remember, for each gram of copper that we dissolve, it will displace about 3.4 grams of pure silver. So if you introduce a feedstock that's high in copper, your electrolyte solution will be depleted. And the more copper you build up in the electrolyte solution, you're no longer purifying silver crystals. You're precipitating copper electrolytically with your silver, and you will wind up with an inferior product that doesn't meet a 3.9 or a 4.9 quality standard. Now let me explain over here. This is some of the silver that you've seen originally. If you'll remember, in our drying process, I told you I have 2 different pans of silver here. One that is clean and one that is dirty. Now this right here that I just run is truly not the ideal product, because I had some copper. And we learned that from whenever I melted it earlier to shot it, you could see the copper oxides forming on the surface. So copper is always a bad thing in an electrolytic refining cell for silver. Now a little bit of copper does good in the electrolyte solution, because it doesn't allow the crystals to adhere to the surface of the stainless steel bowl. But those copper crystals are not precipitating with your silver, so you're still allowing yourself to have an electrolytically pure silver. So the whole point and the whole theory behind the silver cell is to separate the copper from the silver. So in each step of the process, we want to introduce a feedstock that has as little of the trash or the material that we're trying to remove as possible, and that would be copper. Now the reason this system works so good in the electrolytic cell is because it's tolerant of copper up to an extent. Once you reach that threshold of copper, you start refining a product that you really started with in the first place, trying to remove the copper. So what we have here is the silver that was in the pyro cream earlier when I showed you how to dry it. Now, that's a tolerable product for a silver cell right there. That won't deplete your electrolyte too quick. It should come out a good, clean, final quality product. Now, over here on this other side, we have earlier, if you'll remember, the other pyro cream dish that I showed you that was dark gray, and I told you that that was a trashy copper. That's exactly what that is. And what it was it was the last of the silver to precipitate from the nitrate solution. The first crystals that come down will be the purest crystals. The last that falls will be contaminated with copper. They will be intermingled. So the reason that I wound up with these two problems, now this was pretty good, but this one over here is because I had too much nitric. Whenever I got ready to precipitate, I still had free nitric. Now, if you'll remember, I give you numbers earlier in this video. That's why it's so important to follow the numbers. If you get in a hurry, if you don't follow the numbers, if you don't do something that I've told you about in this system, you will not get the results that you want. You will get results, but it will be because you didn't do something right. So follow the directions to a T. Pay very careful attention to the pointers that I'm giving you, and I guarantee you that you'll produce a final quality product. Now, over here, you'll notice this looks golden. Well, what is that? Well, this was a sample of some gold that I had put up that didn't come out of this feedstock, and I'm just showing you for reference purposes. Now, the silver cell is set up to run both coin silver and sterling silver. But we have silver that comes from other feedstocks also. I use this silver for incorporating my gold. I'm a gold refiner. I do karat gold. We have to incord it with silver. This is the silver that's left over. Within this silver, I have some platinum, I have some palladium, and there's actually some gold. That's what gives this silver its golden color. Now, by running this through the cell, I will be able to trap in the filter basket the gold particles and the platinum particles, and I can later recycle that filter to reclaim any gold or platinum that may be in there. Now, below me right here, I have some good silver. Now, this was some silver that sometimes you just hit the nail right on the head. That's exactly what this is. By giving it this type of feedstock, you can run that silver cell or the silver cell that I have designed 2 times longer than you can with this material. I can run the silver cell 4 times longer with this material than I can this material, because the copper is going to deplete the electrolyte. So it's very important that you follow each step and do each procedure the way I've outlined it. If you deviate in any way, I won't be able to help you. In other words, I've set these processes up trying to give you every fail-safe that I believe that may cause you problems. And if you get outside of those parameters, I'm not there to help you. I mean, you can watch this video all day long, but what you're going to have to do is you're going to have to learn from experience. You're going to have to learn from personal experience. You can't learn everything off of the video. But I guarantee you, if you follow these processes the way I have outlined them, I will guarantee you a 98% success rate. And that includes all formulas, all chemicals, all steps, all procedure. You see me right here, right now in front of you doing this, so you know this is possible. If you don't get the results, Well then, don't get discouraged. Do it again. You can always back up and start over. Patience, learning. That's what's going to be the key to the type of product that you produce. Alright. Now what we're going to do now is I'm going to take this shot that we just brought in and we're going to set it up on the hot plate, and you want to heat it for about 15 or 20 minutes to dry it, just like we did our silver powder earlier. And then now we're going to cut away and I'm going to show you how to start getting your cell set up and getting it ready to run this shot. Good afternoon, gentlemen. This segment is going to be on how to pour your candlestick anode bar. And in front of us we have a few items we're going to need. Now your kit should have come with a custom mold. I have these made by a gentleman especially just for the use of the silver cell. We have a flathead screwdriver and we have a pair of channel locks. And over here we have 2 clamps that are going to go on our mold. And here in just a minute I'm going to show you how to assemble the mold. It's nothing more than just lining up the square blocks of graphite and putting these clamps over it and clamping it in place. Now in the back you'll see some silver cells, some silver crystals that we harvested from our cell. Now we're going to need between about 70 and 80 grams of silver to pour this candlestick anode. And this doesn't have to be silver cell crystals. This can be your cemented powder in the very beginning when you're first making these. So what I'm going to do here now is I'm going to cut away just for a second, and I'm going to get to where I can free both hands, and then I'm going to show you how to assemble this mold so we can pour our candlestick anode, and then we're going to go outside and we're going to pour an anode. Alright gentlemen, now we're ready to assemble our candlestick anode mold here. And you just want to take the 2 pieces of graphite, match them together, and kind of square them up. Take one of your clamps and slide it up over it. And on the future ones, the gentleman who makes these molds for me is going to try to put butterfly wing nuts on here because it's a lot easier to handle with just a screwdriver. For these we have to use screwdrivers plus a pair of pliers. So we're just going to stick that up on there. And we're going to take the other one and we're going to do the same thing. And what you want to do is you just want to kind of pick it up and tighten it down snugly. You don't want it real tight. And that will allow our graphite to still shift up underneath there so we can get our plates aligned. And now that we have them kind of snug there, what we'll do is we'll come back and maybe tighten them a 1/4 turn. Just a little bit. You don't want to put a lot of pressure on this graphite. It doesn't take a lot of pressure to hold this mold together. And we're just going to tighten them a little bit. And then if you need to adjust your graphite any, you can loosen them up just a tad bit and your graphite will move back and forth. Graphite is a great lubricant, so this stuff will slide on itself. But as you can see, I've got it pretty well squared up. That's all you're looking for, is just for everything to be lined up. And then like I said, just tighten them about a 1/4 turn. Just enough to put slight pressure on the graphite. You're not trying to torque these down. And then it doesn't move. And we're ready to go outside, and I'm going to show you how to melt and pour your candlestick anode. Now you will need between 70 and 80 grams of cemented silver or crystal silver to pour this anode stick. So you need to have about 70 to 80 grams of cemented or crystal silver to pour this anode stick. So we're going to cut away now, and we're going to go outside, and I'm going to show you how to pour this. Alright gentlemen, here we are outside. We've got our candlestick anode mold in front of us. We have our torch, and notice I have my mold inside of a catch basin right here. Now I would recommend that you find some sort of a catch basin, and I really need one larger than this. I don't melt out here a lot. I do most of my melting in the lab, but I'm doing this and outside again for demonstration purposes. Most of y'all may be doing it in your, in your spare time. Some of y'all may be doing this commercially where you have a lab at. Now over here to the left I have my melting dish, and what I have in here is I have 80 grams of silver. Now again, you could use your cemented powder or you could use the crystals. And this is a bar that I poured out of the 3-9 crystals that come out of the cell. And you can see how pretty and shiny that bar is and how pure that silver is. Well, so either which way, cemented powder or crystals. So I'm going to use this. This is an example of the bar that's going to come out of this mold. And I'm going to remelt this because I was doing something else with it. But this is actually part of the bar that will come out of your mold here. So I'm going to cut away. I'm going to go ahead and get my torch fired up and get my dish heated up here, and I'm going to show you how to warm this mold up. You don't ever want to pour hot silver into a cold mold. You will have a thermal expansion or a steam explosion. This stuff will come back out of here like a shotgun, and until you've ever had molten silver on your skin, it doesn't just come off, it burns in. So you always, again, want to observe proper eye protection and gloves. If you need some, get you some welding gloves. Myself, the heat really don't bother me. I use tongs. My hands are away from the heat source, so I really don't wear gloves. I have learned from past experience, if you don't have gloves on, you tend to want to reach down and grab things, and that's the wrong thing to do when you're working around hot items like this, because everything is hot. Now, after we pour our anode stick in our mold, we're going to have to let this cool for about an hour before you can handle it. This mold, this graphite, holds heat very well. It also dissipates it very well. But over the next hour, our silver will solidify and cool inside of here. It will almost do that immediately anyway. But as it cools off the rest of the temperature, it will start to shrink, and it will free from our graphite mold a lot easier whenever it's cold than when it's hot. So you're going to pour this, and you're going to have to wait about an hour. I'm going to take it back inside after we pour it. We're going to wait an hour. I'm going to take it inside under some better light, and I'm going to disassemble the mold to show you the anode bar that we've poured. So now I'm going to cut away, and we're going to go ahead and get our torch fired up, and we're going to come back and we're going to melt some silver. Alright gentlemen, we're back, and I've preheated my dish like in the previous video. You want to preheat your dish. And what I have here is a bowl that I've used for melting some cement powder. Remember, the silver that you're going to pour in here to make your anode with will be dissolved into your silver cells, so you don't have to use a clean dish for this application. What I'm going to do is I'm going to add some pieces of silver that came from my previous stick that I poured, and we're going to melt that down and use it for this experiment here. And our silver is starting to turn molten now. And you can see it gathering in the bottom of the dish. I'll pull the torch away for a minute and see if we can get a shot of it. And again, see how pretty and clear that silver is? Now what I'm going to do is I'm going to go ahead and I'm going to add my candlestick bar in there. I'm going to let that cool for just a minute so I don't stick it down in that molten silver. And then I'm just going to slide it in there and start to heat it. And it'll start to dissolve in just a second. As you can see, our silver starting to pool in the bottom. Now remember, this is between 70 and 80 grams. I'm using 80 grams for this demonstration. And look how pretty and clean that silver is. That's what you want to see. And now what we want to do, now that we've got our silver hot and molten, we want to come over here and we want to heat this mold up. And we just want to take our torch and just run it up and down the sides. And kind of warm it up, and let's not forget about our silver over here. We want to keep it in a good molten state. And you don't have to spend a lot of time on this graphite mold heating it up. It conducts heat very well. We're trying to drive some residual moisture out of it first off, and then we're trying to heat it up so our silver has time to make it to the bottom before it solidifies. Now, what we're going to do is we're going to take our dish and we're going to position it over the top of the mold, and we're going to bounce the flame off of our dish down into our mold, heating our graphite. We want to bounce it off the lip while we keep our silver molten back here, plus we're preheating our graphite. You just want to balance it on that lip. And after about 10 to 15 seconds of good heat, you just want to tip it up and pour it in there and keep a little heat on top for just a second. Now that's how we pour our candlestick anode, and what we're going to do is we're going to let this cool for about an hour, and then we're going to come back and we're going to disassemble it, and we're going to take a look at what our anode stick looks like. So I'll see you gentlemen in just a few minutes. Alright gentlemen, we're back inside after having poured our candlestick anode and given our mold about an hour to cool so we can handle it real good. Now when we open this up, there's several possibilities to what we could find inside. We could find a perfect specimen of what we're looking for with a rod with a little spur on the end of it, or we could find a half-poured rod. And the reason that is either you didn't heat your graphite and keep it warm enough, or you didn't have the silver hot enough in the dish. It can be one of two, or it can be both. So whenever you're up here with your dish and you're playing the flame off that lip, make sure that it bounces in here to heat this graphite. Graphite is a great conductor of heat. So if you heat it up here, that heat is going to be transferred through the whole body. It's not going to be like heating a piece of aluminum or a piece of steel. This graphite conducts heat well. So hold your dish up here, make sure that you get your silver good and molten. And the more molten you get silver or gold, the more it tends to beat up on the surface of the dish like water does. So you want to play your flame on your silver, bouncing it over the lip and getting your mold all at the same time. And after about 30 seconds of that, you just want to tip it all up. Don't worry about overfilling this. This thing has a cavity that'll hold enough that you can't overfill it if you've used between 70 and 80 grams. So just tip it up, pour it quick, and hold your torch on it for about 15 seconds. Take the torch away, then allow it to cool for 1 hour. Now we're going to break this mold open and see how our candlestick anode come out. We're just going to loosen it up, and the clamp should slide right off. Same way on this bottom section right here. We're just going to loosen it up, and the clamp slides off. And we're going to see what we have inside of our mold here. And voila! We have the perfect specimen of what we're looking for. This is the candlestick anode that you're going to use in your silver cell for making contact with your silver shot. This is what your positive lead will go to. Now, we used a little bit more than we needed in this mold. And sometimes these things can be temperamental. You really don't want to force it. If you'll flip it over sometimes and just barely tap the mold, it'll fall right out. Just like that. And this spur is on here for a reason. You're going to want to stick this down in your basket and fill in around it with shot and attach your positive end right here. All this will dissolve into your electrolyte solution and be precipitated back out of your cell. Now, I use some of the crystals from the cell to make this with. That's why it looks good. But like I said, you could also use your cemented silver. So don't break that off. There's no reason to. You could stick this right into the cell, clip your anode lead up here, and pour your shot around this, and it will work for many baskets full of shot. And whenever you get ready to make another one, you just do the mold the same way and pour you another one. And let me show you just how soft this silver is. Notice how easy I bent that? Pure silver is really, really soft. I mean soft like lead soft, and now I've warped it. But it's just an anode bar, so it really doesn't matter. But it is a real soft metal at this point because it's so pure. So, gentlemen, I guess we finally reached the end of our anode process. So we'll go inside and we'll get our silver basket started up and start making some silver crystals.